Hello everyone. First of all, let me introduce myself. My name is Abdul Rashidum Flihin. You can call me Rido. And we are from Group 10. And welcome to our code walkthrough of our automated water tank filling system. Now, first of all, let's start by checking at our main class, which is the water tank system. Now, inside the initialization method, uh, we have the uh, we have the parameters uh, of our code, which determine the logic of our code, which is the thresholds. Now, the low threshold is set to 20%, which is, for example, when the water level is below 20%, like 10% or 15%, the water pump or the pump state will turn to on. And if the and we set the high threshold to 80%, which is when the pump state is turned off. Now, let's skip to the bottom section and check out the variables. Uh, Now we set the default pump state to off because, like, if there are any errors, the pump state will default to turn to off. And we have the simulated water level at 50%. Why do we have this variable? Because because for testing our code we do not use any physical means. So we use Python's random library to simulate a realistic water level filling. Uh, which will be explained in the next section by Jennifer. Now let's focus on the cycles. Like if there are any errors, we'll count it as one cycle, and we'll give it a max of 10 chances to get it to the level that we want, which is just below 80%. And we set the max sensor error as 3 to act as a safety failsafe. Now that's for me. Next, the simulation of the water level and some other things will be explained by Jennifer.
Now I'm gonna explain about the DEFRIT sensors. So because we aren't using a physical hardware, for this demonstration we need to simulate the real-world water dynamics. Here in the code, with sensor function, we use Python random library. If the pump state is on, the water level increase randomly between 5 and 12%. And if it's off, it decreased by 3 to 8% to stimulate water consumption. Okay, the next one is the self water level underscore sim. So in here, we use the max and the minimum function to keep the water level bounded within realistic physical limits. Notice the block here. We've programmed a 5% chance for the sensor to return a value of minus 99. This simulate a hardware glitch and allows us to test our system error handling.
So my name is Akhtar with the NPM of 25065577072, and I'm going to tell about section 3, which is the heart of the system. That is the run cycle method. So first, it will attempt to read the sensor. And if the value is between 0 to 100, then it will be considered valid, and it will be added to our sum. But if it catches the minus 99 glitch that we made earlier, then it will triggers an error.
Assuming the reading is valid, the system calculates the average water level from the sensor data. This average is then used to control the pump automatically. If the average water level is below 20%, the system understands that the tank is low, so it turns the pump on to start filling the tank. If the water level is above 80%, the system turns the pump off to prevent overflow. If the water level stays between around 20% and 80%, the system keeps the pump in its current state without charging anything. This helps keep the system stable. And finally, the system checks for sensor errors. If too many errors happen continuously, the program activates a safety shutdown by forcing the pump off and stopping the cycle to protect the system.
Okay, now let's look at the execution and the shutdown of the script. So if we press run here, and then we look to the bottom, so we can look at how the execution of the program goes. So first we instantiate our water tank system and print some initial status updates to the terminal. And then we wrap our main loop in a try, except block. A while loop runs the system for our defined maximum of 10 cycles, and then calling run cycle every time and waiting 1 second between each checks. So if run cycle triggers that safety shutdown that we just talked about, it breaks the loop. Furthermore, the keyboard interrupt exception catches if a user manually stops the program by pressing Control plus C. Whether the program finishes its 10 cycles, or it encounters a fatal sensor error, or it is stopped manually, the finally block ensures that a final safety check runs, and then it securely turns the pump off before shutting down completely.